Okay, I'm starting the recording now. So topic is elasticity. We start with exercise 2, which is page 14 in your handouts. So let's recall what elasticity is and what formula do we use for this. Elasticity shows a responsiveness or sensitivity of demand to changes in various factors which will affect demand. So we are talking about price elasticity first. This is the simplest type of elasticity. Could you please pull your mask on top of your nose? Thank you. Thank you. So elasticity shows sensitivity in quantity demanded. It shows how quantity demanded changes due to change in price. So when price changes by certain amount, how quantity demanded will respond? Will it respond by a considerable amount or just by a little bit? And in order to calculate this, we will be using percentage or proportionate terms. So let us start with exercise 2. Here we are given different exercise 2. We are given different values, price and quantity. As price was equal to 16 pounds, quantity was 25. Then price dropped to 14, which increased the quantity to 35. So if we sketch this on a graph, it will look like this. This was our demand curve. We've been located at some point A, where price was 16 and quantity was 25. Then price dropped. This was the change in price, drop in price by that amount. And this led to increase in quantity from 25 to 35 units. We moved from point A to point B. That's the initial layout. And we are asked to calculate the proportionate change when price drops. So what is the proportionate change? In order to calculate the proportionate change, we take the actual change and divide it by the original amount. I've shown this in a lecture. I've shown the full detailed calculations. What is change in price? To calculate change in price, we take new price and subtract old, the original price, and divide by the original price. So the new price is 14. This is where we've ended up. This is the actual current price. The previous, the original price was 16. So the absolute change in price is -2. It means that price drops by 2 pounds. But it doesn't mean a lot for us because we don't know whether this change by 2 pounds is a large or small amount. If we are talking about a product which cost 16 pounds originally, this might be a significant amount. But if we talk about the price of, a Tesla car, which is 50,000 pounds, then obviously price drop by 2 quid is nothing. So in order to determine how significant this price change is, we need to relate this to the original amount, how large this drop is compared to what the price was originally. That's why we need to divide this by the original price. The original price was 16. So we divide our change by 2. 2 is an absolute change. When we divide this by 16, we will get the proportionate change, which is minus 0.125. If we want to turn this into, this is proportionate change. If we want to turn this into percentages, that's easy to do. We simply multiply this by 100, which means that price dropped by 12.5%. So minus 12.5%. That's change in price. In proportionate terms, it's this amount. In percentages, it's this amount. That's what we've done with price. Let's calculate change in quantity. We do this in a similar way. Change in quantity in absolute terms can be calculated as new quantity minus old quantity. Pay attention, new always comes first. We always take new and then subtract old. Here with price, it was quite easy to confuse 14 and 16. It's quite natural to write down 16 minus 14, which will give you 2. This would be incorrect because you are losing the sign. Our price actually drops, so the change will be negative. And in order to account for this, we always take new minus old. Just remember this. So for quantity, the new quantity is 35. Now it's 35, but it used to be 25. So an absolute change will be plus 10. This is an absolute change. Quantity increases by 10 units. But we are asked to calculate proportionate changes. And to do this, we'll need to relate our change to the original amount. Original quantity was 25. New quantity is 35. Original old quantity was 25. So we divide by 25. So 10 is an absolute change divided by 25, which happens to be plus 0.4, will be our proportionate change in quantity. Proportionate change in quantity, plus 0.4. And if we want to turn this into percentages, then we just multiply this by 100%, which means that our quantity has increased by 40%, plus 40%. So that's what we are having. And now we need to calculate the value of elasticity. Recall, elasticity shows how quantity responds to changes in prices. So we need to divide change in quantity in percentage or proportionate terms by change in price. So elasticity is change in quantity divided by change in price. Change in quantity is plus 0.4. Change in price is minus 0.125, which happens to be minus 3.2. Please pay attention. We are keeping the sign. Price elasticity of demand is always negative. So the value of elasticity is minus 3.2. We can use proportionate changes here, or we can use our percentage changes. So quantity increased by 40%, that's our percentage change, and price dropped by minus 12.5%. If we use these values, we will still get the same result, minus 3.2. So in any case, regardless of what you are using, proportionate or percentage changes, you will get the same result. It's just sometimes easier to use one version or another, but the result will be the same. Depending on what data you've got, sometimes it can be easy to calculate percentages, sometimes you can have proportionate changes. Right? And how can we interpret this? As the value of elasticity is greater than unity in absolute terms, if we take absolute value of elasticity, the actual number, ignore the sign, it's 3.2. It's greater than unity, which means that our demand is elastic. It's sensitive. It means that our graph should be drawn like that, strictly speaking. It should be a relatively flat line. It means that a small change in price causes a substantially larger effect on quantity. So change in price is small, while change in quantity is significant for this flat demand, elastic demand. And we remember from the formula that change in elasticity can be calculated as change in quantity, which is large. And we divide this by a relatively small change in price. Insignificant drop in price causes dramatic change in quantity. And because you have a large numerator compared to a small denominator, it implies that the whole fraction will be greater than unity. So 3.2 in our case. So this is the first example, first exercise, very simple basic exercise, right? Which reminds you how to calculate proportionate and percentage changes and how to combine them to get the value for elasticity. Any questions regarding this? You always put the minus, yes. Yes, price elasticity is always negative. It's always, because when quantity goes up, price drops. So this is because price dropped, quantity goes up. When price increases, quantity always drops. So they always move in the opposite directions. We will have plus somewhere and minus elsewhere. So numerator or denominator will always be negative. We'll have one positive value, one negative value. And as a result, the whole fraction will always be negative. Here I'm talking about absolute values. So the actual number, ignoring the sign. So it's minus 3.2, but in absolute terms, I can add this actually so that we never forget about this. But in absolute terms, the number is greater than unity. Shall we proceed with the next one? Okay, so as I mentioned already, there are different formulas for elasticity. If you recall lecture notes, so have a look. We have different versions of the same formula, and so far we've only used this formula with percentages. However, strictly speaking, we can use different versions. For example, this one. This formula relates proportionate changes in quantity and price. So we can use this. Or we can rearrange this formula and write it down differently. Instead of having it in this form, we can just rearrange it and we will get this version. Please remember this, because sometimes it can be easier to use this version instead. And today in this seminar, we'll try to apply different types of this formula. So let's proceed to our next exercise, this one. Here we are just given percentage changes. Exercise 3. So the UK government announced that for every 10% rise in price of cigarettes, demand is likely to fall by 6%. So we'll need to figure out what is the elasticity of demand. This is very simple. So what information do we have? We have 10% rise in the price. right? And demand is going down by 6%. That's all information that we need. Now let's use this data. Exercise 3. So price, change in price in percentage terms is equal to plus 10%. Price goes up by 10%, while quantity demanded drops by 6%. What is elasticity? Very simple. Elasticity is the value of change in quantity divided by change in price. Quantity drops by 6, price increases by 10, the result is minus 0.6. Minus, remember, we always have the minus. The value of elasticity, the actual number, is less than unity in absolute terms, right? Which means that demand is inelastic, which is frequently the case for addictive products, because people they're not so sensitive to changes in price, because it's a habit. You need to buy this product because otherwise you start suffering without it, which means that demand becomes irresponsive or less sensitive to changes in price, and demand curve becomes rather steep, which means that even if price increases by a substantial amount, let's say plus 10%, that's our price change, this only leads to proportionately smaller change in quantity. Quantity drops by significantly less, minus 6% only. That's change in quantity. Demand is inelastic. Again, very simple exercise. Let me maybe open this for you. You are just given the numbers. You don't even need to calculate any changes. You just relate them to each other. Here we go, inelastic demand. So that's this exercise. Very simple. You always keep minus, right? And sometimes you can be asked to interpret the value of elasticity, elastic or inelastic. Sometimes you can be asked to identify, to explain why it is inelastic. There are different factors which affect elasticity of demand. The first and most important factor is availability of substitutes. The more substitutes the product has, the more elastic, the more sensitive demand will be, because consumers can easily switch between alternative products. So demand will respond by a lot when price changes. Another factor would be time. The longer time period you have, the more consumers have opportunities to adjust, and as a result, demand is likely to be more elastic in the longer time period. Next, proportion of income spent on the higher the proportion of income which is spent on goods, the more sensitive demand will be, and addictiveness as well. This is what we've just covered. The more addictive the product is, the more inelastic demand is going to be. Any questions? So these are the basic, absolutely basic exercises. Now let's move on to something slightly, a little bit more complicated. Let's proceed to exercise 4. So here we are given the table, we are asked to calculate elasticity as before, interpret it whether it's elastic or inelastic, and we are also asked to calculate total consumer expenditure. This exercise introduces us to slightly more advanced concept, which we'll use in the next lecture. The thing is, elasticity changes along the same demand line. So I've mentioned previously that, for example, steep demand is inelastic, while flat demand, shown by this graph, for example, is relatively elastic. The problem is, strictly speaking, elasticity varies along the same demand curve. Even if you draw the graph, which is a straight line, moreover, which is 45 degrees line, elasticity will vary. It will not remain the same throughout at each and every point on this demand line. It will not be equal to unity. It will vary at different points on this on this demand line. And this exercise is going to demonstrate this. What I recommend for this particular exercise is that you write down all your steps, all your calculation steps, not just the answer, because otherwise when you will start revising, you won't really remember most of it. You need to know calculations. You need to see the calculations. So let's have a look. Here we are given some demand relationship. We can see how quantity changes as price varies. So we start with a high price equal to 13 pounds. 13 pounds. When price is 13, our quantity is equal to 7. Let's call this point A. So this is point A. Price drops by 2 pounds, becomes 11. Quantity increases by 2 units, 9. Let's call this point B. Next point, point C. Price drops further to 9 pounds. Quantity consumers are buying, increases by the same 2 units to 11. So this will be point C. And the final point is point D, where price dropped even further to 7 pounds and quantity increased by 13. Let's see how this affects consumer expenditure on this product. At point A, consumers are buying 7 units at 13 pounds each, which makes the total expenditure equal to 91 pounds. This is our total revenue because consumer expenditure is firm's revenue. So when we sell 7 units at 13 pounds, our total revenue is 91. Let's imagine that these were our sales yesterday. We've been at point A and we think that, we need to do something about this. We need to increase our sales. What's the best way to promote our product is to drop the price. So we are reducing the price by 2 pounds. Price drops by 2. And as a result, this of course leads to a larger number of customers. We managed to sell 9 units rather than 7. So quantity increases by 2 units plus 2. Price drops by 2 pounds, quantity increases by 2. 9 by 11, we've sold 9 units at 11 pounds each. Our total revenue has increased to 99. Is it better? Better. We've managed to increase our total revenue. Total revenue has increased. Consumer expenditure is the same as firm's revenue because whatever consumers are spending, this is what the firm is getting. It's our revenue. So we can think about this from the producer's point of view, from the business point of view. So we quite like the result, and as a result, next day we think, okay, if it worked today, I'm going to drop price even further, which is likely to lead to even more consumers to my store, and as a result, I will increase my revenue even more. So we drop the price from 11 to 9, so we continue reducing the price by the same amount, by the same minus 2 pounds, which of course leads to more customers. We do get these 2 additional customers. So now at point C, we are selling 11 units at 9 pounds. 11 units at 9 pounds, and our total revenue stalls. It remains unchanged. It didn't increase like last time. We are stuck with the same number. Strange. Okay, maybe something didn't work as it should, so let's just keep doing because the strategy worked previously. Let's see what happens if we drop the price even further, if we move from point C to point D. Should work. We drop the price by the same 2 pounds, so from 9 to 7, price drops by 2. Quantity, of course, increases by 2 units as well. We do get 2 additional customers, so now at point D, we sell 13 units at 7 pounds. 13 units at 7 pounds, and our total revenue happens to be 91. How come? Total revenue dropped. We were doing absolutely the same thing all the time. We were reducing the price by 2 pounds by the same amount, the same 2 pounds. We were gaining the same number of customers all the time. However, strangely enough, our total revenue initially increased. Between point A and point 2, total revenue increased. Then between point B and C, it remained unchanged, total revenue unchanged. And then it actually dropped between point C and D. When we continued moving along the same demand curve, total revenue dropped. How can this be the case? This is because total revenue is related to elasticity. It is elasticity which determines how our total revenue will respond to changes in price. And there was a part in the lecture which described this. I focused on this specifically. There was a separate lecture with this slide. Let me just open this for you. So this was the slide which explained this phenomenon. The same price drops in different markets with different elasticity of demand, with different shapes of demand, will lead to different effect on total revenue. So if we allocated at point A, for example, originally selling the same amount of units in 2 different markets, our original revenue is shown by this blue rectangle. What is total revenue? Total revenue is price times quantity. If we multiply price times quantity, we will get the area of this rectangle under point A. So this blue rectangle is our total revenue originally. If we drop the price goes down, we move to point B along the same demand curve, quantity goes up, and our new revenue will be shown by this purple rectangle, which is obviously larger. If you compare this purple rectangle with the original blue rectangle, we see that we gain considerably more than we lose. We lose this bit, but we gain more. As a result, total revenue increases. When demand is elastic, total revenue goes up. However, when demand is inelastic, the same price drop will lead to considerably smaller increase in quantity. So this additional number of consumers which we are gaining do not compensate us for this price drop per unit. And as a result, total revenue drops. So elasticity is directly linked to total revenue. And this exercise shows us this. So this is exactly what we are experiencing. As total revenue responds differently along the same demand curve, it might be that the value of elasticity is different between these 2 points. So let's check it. And in order to check it, in order to calculate this, I suggest that we use a different formula which will be more applicable, more relevant here. I'm going to use another type of formula, which can be calculated as change in quantity divided by change in price times price divided by quantity. This is the final version of the formula which we saw in lecture, and I told you that sometimes it's better to apply one version or another. This is the case when we are going to use this version of the same formula. P and Q here are original or old prices and quantities, original amounts. So when we start moving from one point to another, these P and Q will relate to what price and quantity were before in the original starting point, right? So let's try to do these calculations. Point A, as we move from point A to point B, quantity demanded drops or increases from 7 to 9, and this is due to price increase, price drop from 13 to 11, sorry. Price drops, quantity increases, right? So let's calculate our elasticity. Yeah, change in quantity is plus 2. It's new quantity minus old quantity. New quantity is 9. Original quantity was 7, so 9 minus 7, it's plus 2. And strictly speaking, we know that quantity will always increase by 2 units. It will remain unchanged. Change in price is minus 2. It's new price minus old price. New price is 11, original price was 13. So change in price is minus 2. And strictly speaking, this component of the formula will remain the same. It will always be the same. Quantity will always increase by 2 and price will always reduce by 2. So that's why it's easier for us to use this formula, because this component, this element will remain the same throughout our demand curve. As we move from point A to point B to point C to point D, this part of the formula will remain unchanged. So that's why it's quite easy. It's equal to minus 1, which means that in order to calculate elasticity, we will only need to add different values of original price and quantity. So let's add our original or old price, and let's add our original or old quantity. So it will be minus 1 times old price used to be 13, old quantity used to be 7, which means that our elasticity is going to be minus 185, which is elastic. It's greater than unity in absolute terms, so between points A and B, demand is elastic. Elasticity is minus 185. Any questions at this stage? Okay, so now let's move between points B and C. Next move between B and C. As we move between points B and C, we want to calculate elasticity, which will be change in quantity divided by change in price times price old divided by quantity old, our formula. Change in quantity and price remain unchanged. Quantity increases by 2 units, from 9 to 11. Price drops by 2 pounds, from 11 to 9. So we only need to plug our values, old price and old quantity. Old price was 11. We start at point B, and this is what this is the price which we used to have, 11 pounds. So old price is 11. What is old quantity at point B? It's 9. We start with 9 units, and then we move away from this point. Original price was 11, original quantity was 9. So this fraction, this part of the formula is the same as before. The only difference will be different original prices and quantities. And the answer here, if you divide 11 by 9, you will get 122. So it's still elastic. In absolute terms, it's greater than unity, but the value is different. So here, our demand between these 2 points is minus 1.22. Still elastic, but considerably lower. Now, let's have a look at this movement, at this segment of the demand curve between points C and D. That's why I asked you to write down the whole solution, so that you will be able to see that this element remains unchanged. To calculate elasticity, we again take change in quantity divided by change in price, which is plus 2 divided by minus 2. But we need to replace our original values, starting values for price and quantity. As we start at point C, this is point C, original price is 9, that's our price, this is where we start, and the original quantity is 11 at point C. So price is 9, quantity is 11. We have the same component as before, plus 2 divided by minus 2, but the values for old prices and quantities will now be different. We start at different bases, and the result will be 0.82. Of course, it's negative, but now it's inelastic, because in absolute terms, it's less than unity. So between point C and D, demand becomes inelastic. And this difference in value for elasticity at different segments of the demand curves between points A and B and between points C and D explains different effect on total revenue. As demand is elastic, price drops leads to increase in total revenue. As elasticity becomes inelastic, less than unity, inelastic, this leads to a reduction in total revenue due to change in price. Elasticity varies along the same demand curve. And this specific version of the formula helps us to understand why. In spite of the fact that we are changing quantities and prices by the same amount in absolute terms, plus 2 and minus 2, as we need to calculate this in percentages, we need to compare this with the original base. Base will be different as we move along the same demand curve. This will change the value of elasticity, this will change the interpretation of elasticity, and this will affect our demand on total revenue. Therefore, the main conclusion from this exercise is that elasticity changes along a linear demand curve. Regardless of its slope, if we have a flat line, it will be relatively more elastic. If we have a steep line, it will be relatively inelastic. But elasticity will vary along the same demand curve. And strictly speaking, if you draw any demand curve, regardless of its shape, there will be a part with elastic demand at the top. So you can see this, that our demand was elastic here. If we located at the top part of the demand curve, demand was elastic. As we move lower down the same demand curve, demand becomes inelastic. There will be inelastic segment. In other words, elasticity drops in absolute terms. Elasticity drops. Here, at this point, the value of elasticity will be equal to infinity. Again, in absolute terms, strictly speaking, it will be minus infinity. And it drops from infinity to some number, 100, 10, 2, 1. Then it becomes lower than 1, less than 1 in absolute terms. 0.9, 0.8, 0.5, 0.1, and then eventually it becomes equal to 0 at the point where demand curve crosses horizontal axis. So please bear this in mind, because we will use this graph in one of the next lectures when we'll start analyzing total revenue for the company, because it has a direct application for firms' decisions. In order to maximize firms' profit, we'll need to find the maximum difference between total revenue and costs. So this week we are studying costs, production theory of costs. We'll learn how cost curves look like for the company. And then we'll need to relate them to combine this production theory with the demand theory and find the best difference, the best gap between total revenue and total costs, which will show the maximum profit. We will learn how to identify the best possible, the optimal production level, which will maximize the profit for the company. We will learn a simple formula which will tell us how much exactly, how many units a company needs to produce in order to earn the highest possible profit. We will learn that in order to maximize your profit, you don't need to produce the maximum amount. For me, when I was a student, this was a revelation. I always thought that the more customers you serve, the richer you become, the higher is your profit. This is absolutely not the case. There is some optimal amount of customers which you need to serve. If you expand your output too much, your costs increase quicker than your revenue and you lose out. There is an optimal amount, and we will learn this. And we will use this graph based on this concept which we've just covered, the fact that elasticity varies, in order to derive this optimal quantity. So please bear this in mind. This is the main lesson from this particular exercise. Questions? I'm ready to answer your questions. Did you have a question? Because it looked like you were raising your hand. No? Is this clear? Yeah, so this is, I quite like this exercise because it shows so much. It shows how you can apply different versions of the formula and how easy it is. Rather than calculating percentages all the time, you just plug in different numbers, so you save time. You only divide 11 by 9, for example, or 9 by 11, because the first part of the formula was calculated for you already. So it's just quick and simple, and it shows you exactly why elasticity varies. You don't just get random numbers, you see how and why you've got these particular numbers which led to this particular outcome. Okay? Right? So that's why I do recommend that you become comfortable with different versions of formula for elasticity, because sometimes it's just easier to use one version or another. For example, in this exercise with demand for cigarettes, you were given percentages, you just divide one by another. But if you have something like this data, sometimes it's easier to use a different version of the formula. Okay, if there are no questions, let's have a look at exercise 5. I'll give you a minute. Try to do it yourself. It's very simple. There are two items, and we need to decide which one is likely to have more elastic demand. So more elastic demand. There are two products, for example, all brands of petrol and a specific petrol sold at a particular brand, particular petrol station, like ESSO petrol, for example. Which one is likely to have more elastic demand? ESSO petrol, because strictly speaking, it has different number of substitutes. Petrol overall, general petrol, doesn't have many substitutes. If you need to drive a car, you cannot fill your car with anything else. You cannot even fill it with diesel if you have if you have an engine which runs on petrol. You cannot fill it with alcohol. You cannot fill it with milk. It doesn't have any substitutes. You need to use petrol to be able to use your car, right? While ESSO petrol will have plenty of substitutes. If you're not happy with its quality or price, you can easily drive to another petrol station and buy it elsewhere. Some different type of petrol, different brand of petrol. That's why, of course, customers are likely to be much more sensitive to changes in price for ESSO petrol compared to petrol overall. Right? They won't be able to switch easily away from using their cars if petrol overall becomes more expensive. But if only one brand increases their price, they will easily just drive to another petrol station next time. Got this? Any questions? Okay, next, holidays abroad and bread, which is likely to be more elastic. Holidays abroad is likely to be more elastic. Again, for two reasons. First of all, because there are more substitutes for holidays abroad. If holidays abroad are too expensive, you can switch to different destination. For example, if Turkish holidays become expensive, you can travel to Italy or to France if you want to have a holiday abroad. Or even if all holidays abroad become far too expensive, maybe because of the exchange rate of the pound, which depreciated dramatically, you can have nice holidays within the UK. You can still entertain and have quite good time and still enjoy yourself. So you won't lose out that much. So if particular type of holidays abroad become too expensive, you will be quite sensitive because there are many substitutes for this. You can still have fun by doing something totally different. But on another hand, there is another factor which affects elasticity of this particular product. You spend a lot on holidays abroad. It's likely to cost you maybe 1,000, maybe several thousand pounds per family when you travel elsewhere, especially if you travel far away to America or Australia. Yeah, you are likely to spend several thousand pounds, and you are likely to be very sensitive to changes in air tickets, for example, cost of airfares or hotels, because you spend so much. While bread is more or less basic necessity. Yes, you can still switch away from bread, and there are different types of bread. You can start buying, I don't know, pitas, for example, or baguettes, French baguettes, or any other types, or buns, any type of bread. But you spend considerably lower proportion of your income on bread. So even if cost of bread doubles, you will not suffer that much compared to if price of holidays doubles, for example. You will not be so badly affected. And as a result, consumers are less likely to switch away from bread altogether if it increases in price considerably. While they can easily decide not to have a holiday abroad if the price is too high, simply because they can't afford it. It's too much for their budget. Okay? And a similar question about salt and clothing, which is likely to have more elastic demand. It's clothing, because again you spend considerably more on clothing compared to salt. I personally don't know how much salt costs. I buy it maybe, I buy the whole large pack maybe once a year or something, and even if it doubles, I won't even remember this, simply because I won't remember what the original price was. And in any case, I'm not going to start using less salt simply because it's 2 pounds rather than 1 pound. It's ridiculous, because every time I'm using so much, so tiny amount. It's a share of a penny, or maybe 1/1000th of a penny each time I use it, and I don't really care how much it costs, because it's so small, insignificant proportion of my income. So because you spend considerably more on clothing, the demand is likely to be much more sensitive compared to demand for clothing. So this exercise illustrates different factors which can affect elasticity of demand. So when you run a business or when you work for a company, if you need to do some analysis, if you need to do some predictions of how consumers can respond to changes in price, think about the type of product you are selling, because this will determine what would be better for you, to increase the price or reduce the price. It will determine elasticity of demand, and it will affect your pricing decisions. And pricing decisions is an important part of the firm's strategy. It can determine whether you are successful on the market or not, what price you charge, how competitive you are on prices. Any questions? Shall we go through exercise 6? Again, I'll give you maybe 5 minutes trying to do this. It might be slightly more complex for you, but try to do it yourself, and then I will explain the answer. Right, so this exercise gives you 2 graphs, labels a few points, and asks you to compare, to answer a few questions, whether it's true or false. So strictly speaking, it's based on the same information, but might be slightly more complicated. At least this is what I've learned from my previous years in seminars. This is what I see frequently. So first statement, demand is more elastic between prices P0 and P1 along curve D2, which is red curve, compared to curve D1. So the statement is that this segment, this part, is more elastic compared to that part. Is it true or false? It is true, yes, because it's flatter, because the same drop in price leads to different changes in quantity. So let me just probably use different colors to make it easier to understand. The same drop in price leads to this large change in quantity for demand 2 and significantly smaller change in quantity, this change in quantity for demand 1, for blue demand. In other words, change in quantity demanded 1 is proportionately smaller compared to change in quantity demanded for the red line, for the same price change. Price changes by the same amount, but our numerators will be different. Red numerator will be larger, while blue numerator will be smaller. And as a result, of course, the value of elasticity for demand 2 will be larger than the value of elasticity for demand 1. We're relating to the same point. Our starting basic original amount, original quantity and price is the same, but quantity increases by significantly more along the same red line. So when we start at the same point, red line, flatter line, will have more elastic demand. Next question asks you to write down the formula for elasticity between certain points. Strictly speaking, what I would suggest is to write down the formula first and then compare it with what is given to see whether it's true or false, because it might be quite difficult to identify at first. So we need to find price elasticity of demand between these 2 points, P0 and P1, in the case of curve D2. So we're only looking at red curve, and we need to write down elasticity between, let's say, points A and point B. This will be easier to understand. We're only focusing on these points. So at point, to calculate elasticity, we'll need to compare change in quantity to change in price and relate to the original or old price divided by original or old quantity. So let's just plug in the values. Change in quantity is change in quantity can be calculated as new quantity minus old quantity. Change in price can be calculated as new price minus old price. So basically this is our first element, first part of the formula, and then we need to multiply this by old price and old quantities. So this is the formula which we'll need to construct. Let's plug in the values. New quantity, if we move from point A to point B, new quantity is going to be Q2, as far as I can see, Q2. Minus old quantity, next element, old quantity. Original quantity at point A used to be Q0. Next, denominator, prices, price new minus price old. At point B, new price is equal to P1, plug it in. Original old price at point A used to be P0, plug it in. We've got our first term. We've managed to write down this part of the formula. Now we are focusing on the second part, on this. Price old. Original old price at point A used to be P0, and quantity old at point A used to be Q0 too. That's the formula which describes the elasticity of demand for our segment between points A and point B. This is the correct formula, and now let's compare it with what we were given. Is it the same? No, it's not the same, because first part is correct, but here we are relating to the wrong base. We are relating to the new quantity rather than old. That is why this would be incorrect, and the correct answer which you should have chosen is false. False is the right answer, because in our formula this element is incorrect. We need to relate to the original P0 and Q0 rather than P1 and Q1. Any questions? And the last part of this exercise, again, another statement. For any given change in price, there will be a larger proportionate change in quantity along curve D than along curve D1 than along curve D2. This wouldn't be correct. So because along the steeper line, let me draw it this way, separating into two graphs, D1 and D2, flatter line and steeper line. We have the same given change in price. Let's vary price by the same amount. This is change in price. It's the same in both graphs, in both types of market. The same change in price will take us from point A to point B in both graphs, in both markets. The thing is, they will be located at different places. In the first graph, change in quantity will be very small. This will be this small change in quantity. While in the second graph, the same proportionate change in price will lead to considerably larger change in quantity. Very small, tiny change compared to very large, tiny change. Why it is proportionately different? Because to calculate proportionate changes, we always relate to the base, to relate to the original amount. And in our scenario, we always originate at the same point A. This is our point A. We always compare our actual absolute change to this point, to the original price and to the original quantity. They're the same in both cases. We always start at Q0 in both cases. We always start at P0 in both cases. So proportionate changes in price will be the same, but proportionate change in quantity will be considerably smaller in the case of a blue demand curve 1 compared to the flatter red demand curve 2. So that's why the answer would be false. There will be a larger proportionate change along this curve, D2, rather than D1. So the opposite is true, and that is why this statement is false. So larger change along 2, not D1. The opposite is correct. Okay? Next exercise. I think we've covered more or less everything here. Next very simple exercise. Have a look at exercise 7. Income elasticity of demand. Please write down the formula and recall what exactly it means. Right? Income elasticity. Income elasticity is not always negative. It doesn't have to be negative, unlike price elasticity. Income elasticity can be both negative and positive. When it's positive, it implies that both elements, change in quantity and change in income, that they move in the same direction. When income goes up, quantity goes up as well, which means that the good is normal good when income elasticity is positive, greater than 0. It means that our fractions, parts of the fraction, numerator and denominator, move in the same direction. If income increases, quantity increases too. Plus and plus will give us positive number, positive fraction. When income drops, quantity demanded drops as well. We will have minus and minus. As a result, we'll still have a positive value. So this means that the good is normal. However, there are some different types of goods, inferior goods, And for them, income elasticity will be less than unity. This will be the situation when our quantity will drop, for example, when our income increases. Quantity and income, of course, in percentage terms, they move in the opposite directions. When income goes up, quantity demanded drops. Example would be like value products, Tesco value instant noodles. They cost something like 20p. They're edible, there is nothing wrong with them, but if you become richer, you will start buying them less and less and less because they are not so attractive product to you. You will move away from this product to something more preferable. So this would be an inferior product. So the sign of elasticity can be different. It can be both positive and negative. And you can use this information to find out how customers or what customers think about your product. Do you prefer it or not? And it will also affect demand for your products depending on the stage of the business cycle. Because in a business cycle, when economy is booming, consumers' income will increase. In recession, consumer income will drop. And by knowing the stage of the business cycle, you can get this from the news. You know more or less that now our economy is not doing so well. So consumer income is not as high as it used to be. So consumers are losing out because people lose jobs, they become redundant because of coronavirus, they cannot get paid, their businesses are shut, income drops. And if you know how they think about your product, if you know the income elasticity of demand, you can predict how this will affect demand for your goods and your sales and your profit for your own business. So let's have a look. Which you would expect to have a demand which is elastic with respect to income. Flour, is it likely to have a very elastic, very sensitive demand with respect to income? No, correct. Why is it inelastic? I can't hear you. Say louder, please. Flour, it's an inferior good. Do you agree? Pay attention. We are talking about elasticity, which means the number for elasticity, not the sign. Sign will determine whether the good is normal or elastic. But if the good is normal, majority of goods are normal, it's still likely to have elastic or inelastic demand, which means that consumers are likely to buy significantly more flour when their income increases and significantly less flour when their income drops. Or they're likely to buy more or less the same quantity regardless of their level of income. Does it help to think a little bit about this? So, okay, income elasticity of flour is unlikely to be very elastic. Demand is unlikely to be very elastic with respect to income. I will explain why, and hopefully you will get what I want to hear from you. For flour is more or less a basic necessity, it's more or less a basic product. You use it to cook different meals for your family. For example, you can make pancakes, or you can add this to sauces or something like this. So you basically use it for baking. When you become richer, are you likely to start baking significantly more? Or will you start suddenly cooking pancakes twice as more frequently? Probably not. Maybe you will start buying it more. Maybe you will switch to a different brand, maybe more expensive brand, or maybe some organic flour or something fancy type of flour, like, I don't know, coconut flour, whatever. But you are not likely to start using significantly more flour. Another illustration would be milk or toothpaste. Are you likely to start using more toothpaste because you've got a better paying job? No. Why? You still need just some amount. You are not likely to use more. Or salt? Are you likely to start using like more salt simply because you can afford to buy more? No. These particular products are basic necessities, which means that you are likely to consume more or less the same amount, more or less. It might increase, you might start buying more, but not significantly more. When your income, for example, triples, you will not buy triple amounts of flour. So demand is likely to be not very sensitive. Okay, ready prepared meals for the microwave. Are they likely to be sensitive? Yes, absolutely correct. This is likely to be more sensitive to changes in income. Let's imagine that the ready-made microwave meal costs like £3. Yeah, 2-3 pounds, a nice meal. It's decent, it's tasty, but it's rather bloody expensive. So I personally quite prefer to just grab something from the freezer, put it in the microwave, and in 5 minutes I can enjoy my meal, which is nice and tasty. It can be healthy, can be organic, can be very delicious, and you can select it based on your diet, or you can have vegan one, or you can have halal, or you can have different versions. They're nice, but they're expensive. And if you need to feed the whole family, it costs lots of money, which means that if you're a student, for example, even if you prefer the convenience of this, you simply cannot afford to have them every day because they're expensive, right? Well, when you become a very busy executive, for example, you don't have your own cook, but you are quite wealthy, you can afford this, and your time costs significant amount of money. You earn quite a lot, let's say £100 per hour. Would you rather spend this hour cooking, or would you rather spend it on something else? If you can just have your meal in 5 minutes, would you try to cook it from scratch? If you're earning £100 per hour, you would probably maybe work for half an hour and have your lunch for half an hour, and you would still be better off, right? Does it make sense? So microwave meals, ready-made microwave meals, are likely to be much more sensitive to consumer income. When consumers become richer, for example, because unemployment is low, economy is booming, everyone is paid really well, demand for these products is likely to increase, and your business, if you're selling this type of product, is likely to do well. And in recession, consumers will switch away from these more or less luxuries, and they will start moving towards basic necessities, and your demand, your sales are likely to suffer. Champagne. Is it likely to have very elastic demand with respect to income? Yes. So it's, again, it's not a basic product, and when you are rich, you can afford to have a bath filled with champagne. But if you are a poor person, you are unlikely to buy expensive proper champagne very frequently. You can buy it occasionally on a special day, but definitely you won't be able to drink it regularly because it's expensive. Socks. No, it's basic necessity, but interestingly here, my answer tells that it's possibly, if we're talking about designer socks, for example. Basic socks, like from Asda or from Pound Store, of course, it's a basic necessity. You just buy them, and you buy them as many as you need. You won't buy them more because you can afford to have more. But if we talk about maybe designer socks from, I don't know, John Lewis, which cost £50 a pair, or some like luxury brand like Ralph Lauren or Pierre Cardin or whatever designer socks, then probably yes, you will probably buy this more when you become richer. Yeah. So we can talk about different brands or types of luxury branded products versus like basic products. So maybe basic socks, no, they're not sensitive to income changes because you still need to put something on your feet, right? But if you're talking about designer, then maybe. Designer jeans, yeah, similar idea. You will probably still need to put something on your bum to cover up yourself. You still need to have some trousers, some pants. But if we talk about designer jeans, which are considerably more expensive compared to basic brands, then yes, they're likely to be more sensitive to changes in your income. Electricity, probably not. So also maybe possibly, maybe I would put here possibly, if we are talking about some additional devices which consume lots of electricity. For example, you can have an air conditioner which creates a really nice, lively climate in your house. You are likely to have this installed if you can afford it. If you can afford to install it and run it, because it consumes electricity, right? Or I don't know, automated vacuum cleaner which is installed in walls. When you build a house, you can have a vacuum cleaner installed inside the walls, and basically there will be a hole, a connection outlet, and it's much more easier to clean your house, and it's likely to consume more electricity, but you're likely to have this device when you are quite wealthy. Normal person wouldn't be able to afford this. Or automated blinds, or smart house systems, like smart security systems or lighting systems or whatever, which adjusts to your mood. It's likely to run on computers, which will consume electricity. So probably a richer person will have more devices installed in their computer, which are likely to consume more electricity. So possibly, it depends how we interpret this. Bus journeys, are they likely to be sensitive to changes in income? Probably not, because if you need to travel, you have to travel. And yeah, if you need to get from point A to point B, if you cannot walk, if you cannot use a cycle, sometimes you can't. Between cities, for example, you won't be able to travel by bike on a motorway, so you'll need to buy a bus ticket. So it's likely to be less sensitive, less elastic. Insurance, possibly, again, it depends on the type of insurance. So wealthier people are likely to have more insurance products, and the poor person is likely to take more risks simply because they cannot afford to pay insurance. They would love to be protected, but it's just costly. They cannot afford to spend, I don't know, £100 per month on some possible risks to protect from risks, simply because they need to spend this money on food, for example, and they cannot just spare this amount from their budget. So possibly it might be sensitive, might be sensitive to changes in income. Okay, so I think we've covered all exercises for elasticity. So hopefully you will be able to do this. There will be definitely questions, of course, in exam asking you to calculate elasticity, to interpret elasticity. So for example, if I tell you that income elasticity is -3, what sort of good are we talking about? Or what sort of elasticity, positive or negative, is likely to be for substitute products? These are sort of questions which you can expect. You can expect calculations and interpretation for elasticity.